Okay, so in this video, we're going to look at writing half reactions for redox. Again, with redox, we're looking at the exchange of electrons as the reaction proceeds, where something is going to be losing electrons and something else is going to be gaining electrons. So the easiest way to do this is to determine which elements gain and lose electrons in the reaction. So our steps are going to be, first, assign oxidation numbers to everything that is in my reaction. So go through and see what the charge of each individual element is. And then look for changes in oxidation number. What was the oxidation number of the particular element on the reactant side versus what is it on the product side, and see where the changes have occurred. And we use the little acronym LEO the lion says grr, or LEO says grr. LEO stands for lose electrons is oxidation, and grr, gain electrons, is reduction. And so I can look and tell what is occurring based on this idea. It's also important to realize the relationship between what is being oxidized and what is being reduced. So when one member of our reaction is oxidized, meaning it loses electrons, something else has to gain the electrons. In a sense, you can say that it's providing the electrons for the other partner to gain. So it is the agent of the reduction. So we call it the reducing agent. So whatever is oxidized is our reducing agent. They are always paired that way. And if we look at it from the other direction, when one member of the reaction is reduced, meaning it gains electrons, it had to essentially pull or steal those electrons from something else. So it causes its redox partner to lose electrons. Therefore, we say it's the oxidizing agent. So remember, when I'm asking you to identify what's being oxidized, what's being reduced, who's the reducing agent, who's the oxidizing agent. Whoever is oxidized is your reducing agent. Whoever is reduced is your oxidizing agent. Okay? So we're going to look at this example. And again, the first thing we're going to do is go through, we're going to assign oxidation numbers. So calcium here and oxygen are solo. So they're going to have a 0 charge for oxidation number. And then on this side, calcium and oxygen are paired. Calcium is going to be a +2 because it's in the 2A column. Oxygen is going to be -2 because, well, oxygen's -2 unless it's a peroxide or with fluorine. So now look and see what's happened. Well, calcium went from having 0 charge to having a +2 charge. So it lost electrons. If it lost electrons, we say that this was oxidized. And I'm going to abbreviate that by saying OX. Then oxygen went from being 0 to -2. So it gained electrons. And if it gained electrons, we're going to say it was reduced. Okay? So we'll abbreviate that RED. So if our oxygen was reduced, then we know it's the oxidizing agent. And if our calcium was oxidized, then I know it's the reducing agent. So let's go ahead and get that written down. So Ca is reduced. Therefore, it's the oxidizing agent. And then O is oxidized. Therefore, it's the reducing agent. Remember, they do go hand in hand. So the next thing that we want to look at is we need to write the half reactions for these. So what's occurring in each reaction? So we're going to break it up based on the reduction half reaction and the oxidation half reaction. So in the reduction half reaction, I'm only writing the things that are reduced. So in my reduction half reaction, the oxygen is reduced. So I'm going to write O2 arrow O -2. The oxygen went from being O2 to now it's the ion O -2. All right. And then for what is oxidized, that's my calcium, calcium arrow Ca +2. All right. So now I've got to also look and see what's going on here in terms of my balancing. I have 2 oxygens here. Let me put this in a different color so you can see what I'm adding. I have 2 oxygens here, and I only have 1 here, so I'm going to place a 2, and that'll take care of my balancing. And now I need to talk about what's happening with my electrons. Now remember that whatever's being reduced is gaining electrons. So that means that those electrons go on my reactant side. So I'm going to have to add some electrons here. When I'm adding these electrons, there are a couple things you need to remember is that each electron is going to make 1 negative charge, And so here we have 2 negative charges, that'd be 2 electrons, but I have 2 oxygens with the 2 negative charges. So really what I'm adding is 4 electrons. Okay, so 4 electrons are being transferred. All right, so this is a balanced reaction. 2 times -2 is -4, and then I have -4, so everything is balanced here. We're good. Now let's look at the calcium. So calcium is going from Ca to Ca+2, and we know it's losing electrons. That means the electrons have to be on the product side. I'm going to produce, for 1 calcium, producing 1 Ca+2, 2 electrons. Okay? But remember, whatever electrons are lost by the calcium have to be gained by the oxygen, and I can't lose 2 here and pick up 4 here. So I need to make this number of electrons equal, so I'm going to multiply this all by 2. That's going to make this 2 and this 2, and change this from 2 to 4. So I now know that 2 calciums are losing 2 electrons each to make 4 total electrons, and those 4 total electrons are transferred to the oxygen, which gains those 4 electrons to make 2 O-2 ions. Okay? All right, let's look at another example. All right, so in this next example, I have 2 HCl plus Mg yields MgCl2 plus H2. So I'm going to label my charges. It's easiest, I find, to start with the ones that are by themselves. So I know that magnesium is 0 and that hydrogen is 0. And then start looking at what's paired up. So I know hydrogen is going to be +1, chlorine has to be -1, magnesium is +2 in 2A, chlorine is -1. There's 2 of them, but each one is only -1. So then looking at what's being oxidized and what's being reduced, the hydrogen is going from +1 to 0, so it gained electrons, therefore it was reduced. Magnesium went from 0 to -2, or I'm sorry, 0 to +2, so it lost electrons, therefore was oxidized. Okay? So if I can say hydrogen is reduced, therefore is the oxidizing agent. Okay? And magnesium was oxidized, therefore is the reducing agent. All right. So in terms of our half reactions, let's get those written down. So for my half reaction, for my reduction, I've got the H plus, and that's going to be producing the H2. And then I have, for the oxidizing, the Mg, and that's going to be producing the Mg+2. Okay. In terms of my balancing, I have 2 hydrogens on my product side, so I'm going to need a 2 coefficient here. And then I need to see where my electrons come into play. So 2 hydrogens each gain 1 electron, and so we're going to add 2 electrons. And then for my magnesium, 1 magnesium loses 2 electrons, 2 electrons. That one was pretty easy. All right, let's look at our last one down here. So first things first, we're going to label our oxidation numbers. So by itself 0, by itself 0. Aluminum is in 3A, so I know this is +3. And I can go through and I can label these for the hydroxide, but notice that it's hydroxide here and hydroxide here, so it probably didn't change. And I'll show you to demonstrate that, but if it's hydroxide and hydroxide, they're going to be the same. We know this is -2, we know that this is +1. I know overall hydroxide has a -1 charge, and that makes sense with what I have here. -2, +1, this has to be +1. So the hydroxide, again, didn't change. So I look at my aluminum. My aluminum went from 0 to +3, so it lost electrons, therefore was oxidized. My sodium went from +1 to 0, so it gained electrons, therefore it was reduced. All right. So when I classify these things, again, aluminum, oxidized, therefore is the reducing agent. Sodium is reduced, therefore is the oxidizing agent. All right, let's write our half reactions here. So I'm going to separate my two parts. My reduction half is going to be my sodium, so Na plus 1 is going to make Na, and then my oxidizing half is going to be aluminum yields Al plus 3. Okay, so let's see what we need to add. So the sodium is going to pick up 1 electron to become the sodium atom. All right, that one was easy. All right, now let's see what's happening down here. The aluminum is going to be losing 3 electrons. All right, well, can I have 1 and 3? Nope, I need to have 3 and 3. So I'm going to multiply this one by 3, and now I'm good. All right, so you should be able to write half reactions. In our next video, we're going to look at balancing redox equations by the half reaction method. So this separating of them will be the first step that you would do for that.